should.
Okay. Let's get to slide number 19 is where we're going to pick up. We really only have one more topic. We're not going to get through too much more of these notes, which is fine, because we're going to actually start into our last project, and it's going to take about a week, so I need that time. So really we're just going to kind of wrap up this idea of total mechanical energy, and the idea that you can have kinetic, you can have potential, and as one goes up, the other has to go down, and that when you add them together, they equal the total. Okay, go ahead and close that up for me. So we're going to start really simply. So on slide number 19, it wants us to find the potential energy and the kinetic energy, and certain pieces of information are given at certain locations. Sorry, trying to get that little box off. So here we have 0 kinetic, which makes sense because we're at the very top, so that means we'd have to have all potential. Here we have 25 joules of potential, we do not know the kinetic, and down here we have 50 joules of kinetic and 0 joules of potential. So if we use the idea of total mechanical energy, the equation for total mechanical, and I'll put that over here, is TME equals KE plus PE. Alright, so if we have our kinetic and we have our potential, like they give us here, what's our total for this system? For this little ramp system, what is our total mechanical energy? 50 joules, right? So if we know that we have 50 joules total, then we can use that to help us figure out these two. So if I have 0 of kinetic and I have a total of 50 joules, what does my potential have to be? Has to be 50, right? And then over here, if I take, we can set it up kind of like a simple algebra equation. If I have my total we know is 50, oh, really humming, and my potential is 25, and my kinetic is unknown, how am I going to figure out my kinetic? What do I do?
Subtract the total by what we already have.
Perfect. So we have 25. It's adding, so the inverse of that would be subtraction. So that turns to 0, and we subtract it over here, and we get 25 equals kinetic. So we fill in our 25 joules here, we fill in our 50 joules here, and that completes our problem. So being able to have that last piece of information where total mechanical is equal to KE plus PE allows us to kind of figure out if we have an unknown amount at one of our positions. Okay, so let me, hopefully things get a little better. My computer has been super slow, kind of glitchy, twitchy. Hopefully that doesn't, we'll see what's going on. No. Maybe I shouldn't have said anything we didn't say. Okay, so what I do on the next screen, I have left you room on your paper, right? There's room to the right and there's room below that little diagram. You're gonna have to kind of write small, but you're gonna need to make sure that you are doing this work, all right? Because we're gonna do some practice. Like this is gonna kind of wrap it up and put everything that we've talked about so far together. Okay, so it says calculate the potential energy, the kinetic energy, and the mechanical energy, which is the total mechanical, the velocity and the height of the skater at these various locations. Okay, so you can see at position 1, it has these 3 blanks. At position 2, it has 4 blanks. At position 3, it has 5 blanks. Here it says a height of 1 meter. We do not know the height here though. And down here, we're not given anything. But for the entire problem, the mass is 50 kilograms and the velocity is 7 meters per second to get started. Okay, so we're gonna be given just enough information to be able to figure out all of the pieces that are unknown, okay? And so we're gonna just kind of walk through this. I'm gonna write myself a little reminder, because these values change, so I wanna make sure I remember when I switch my screen. Okay, so I'm gonna go over here, and so I have basically what you have now. To start, I'm gonna make sure that I do not forget that my mass, and I'm gonna put this mass equals 50 kilograms. Sorry, I'm gonna need to calibrate this. The mass is gonna stay the same throughout the whole system because it's the same skateboard rider and skateboard. So that mass is not changing. It's still the same person, still the same equipment. The velocity that's given, that's gonna stand just for that first position at part one, at stage one or part one. Okay. So that was my mass and my velocity, and actually I'm gonna put it down here. My velocity is 7 meters per second. Okay? So from there, I'm gonna make sure that I'm using my 50 every time that I need to, but my velocity of 7 just this first time. So when I'm looking at this, the first thing I'm gonna ask myself is, okay, I have mass and I have velocity. Which equation, and I've rewritten things up on the board, but which equation has mass and velocity in it? My kinetic or my potential? Kinetic. All right, so for my kinetic equation, if I plug in my 50 and I plug in my velocity, I should be able to calculate my kinetic. So, if I take my equation of KE equals 1/2 mass times V squared, right? And so I would like you to be writing this on your paper, right? Whatever I do, I would like you to do as well. So my kinetic is my unknown. I don't know that value. So I'm gonna find 1/2 of my mass, which is 50, times my velocity, which is 7, and I have to make sure I square that. So I'm gonna just keep bringing down, and this is the same process that we've used this whole unit. Half of 50 is what? If I take 50 divided by 2, what do I get? 25. All right, and then I bring down my multiplication, and I can also simplify my 7 squared, and what does that become? 49. Okay, so now I'm taking my 49 and my 25. What do I get when I multiply those two together? What do we get? Austin, do you have that?
1,225.
All right. So my kinetic is going to be 1,225 joules. So I can fill that in, 1,225, and I include my units of the capital J. Now, let's think logically here. I'm at the very lowest point. If I am at the reference point or the ground, how much potential do I have? Yeah, 0, because you have 0 height. So really, we can fill in that there's going to be 0 potential at that point. So if we know that the potential energy is 0, because if you take mass times gravity times 0 height, you get 0. So if I have 0 potential, what's my total mechanical going to be? Here it says ME. If you want to put the T, this is our total mechanical. What's our total mechanical going to be? Anthony, what do you think? Okay, so my total is 1,225 joules. Well, didn't we say that the total stays the total for the whole problem? So now that with the energy diagrams, the bars stayed the same height, but now that we actually have a number for that energy, we can fill that in. So that 1,225 is going to be our total that we're going to reach at every position or every step of this ramp problem. Good so far? Okay, so now we have everything completed for part one. We just had to do our kinetic equation. So I'm gonna switch my color. I'm gonna go to blue just so it kind of stands out a little bit. Now I'm gonna go over here. I do not know my velocity because it's not 7 anymore. Because as you go up the ramp, think about it. It kind of makes sense that do you think you're gonna speed up as you go up the ramp, or are you gonna slow down as you go up the ramp? Just kind of logically, what do you think? You're going at a certain speed or velocity, and as you go up, going uphill, do you speed up or slow down? Probably should slow down. So we had started at 7, so in my mind, I'm thinking logically, I'm probably gonna have a value for my velocity that's less than 7, if these make sense. But I am given the height here, so I'm gonna put h equals 1 meter. That's given, and that's kind of easy to miss and be like, oh my gosh, I don't have enough information, I can't solve anything. But if I have height, which one of our equations has height in it? And I love it, I can see some of your eyes looking over to the board. Which one of our equations, Dewey, has height? Is it the kinetic or the potential? Good. So I'm going to put my GPE is equal to my mass times gravity times height. And the mass is 50, right? And my gravity is what? 10. And then in this example, or this stage, the height is 1 meter. So you just complete that math. 50 times 10 times 1 is how much? 500. And so now we can fill in our PE, and it is 500 joules. Well, I don't know my kinetic and I don't know my velocity. Those are two variables that are in that equation, so I can't solve it if I only have the mass, right? So what can I do? Where do I go from here?
Subtract the potential from the total.
Okay, we can use our total mechanical, right? So I can take my TME equals KE plus PE, right? And if I fill in what I know, and again, please make sure that you're doing this work on your paper as well. So if I fill in my 1225, I do not know my KE, but I'm adding that to my 500. So how do I get KE alone?
Subtract 500.
Good. The inverse of addition is subtraction. So I'm going to subtract 500, gets rid of it over there, but the rules of algebra say whatever I do to one side, I have to do to the other. So when I do the subtraction, you get 725 joules for my KE. And if you want to check to make sure you did it right, you could add those back up and make sure that you do get your 1225, and you do. Now that we have our total, we also still have our mass, so that means we can solve for velocity from our kinetic equation. All right, so there's always that the velocity is unique to kinetic energy, the height is unique to the potential energy, so whichever variable you're given, that's the equation you start with. So we're given height, so that's why we started with GPE. Now we're solving for velocity, and so we have to go to the kinetic equation. So from there, I'm going to do my KE equals 1/2 mass times V squared. I'm going to fill in the things that I know. I know 725 for my kinetic. I know 1/2 of my mass is 50 times V squared. So I'm going to simplify or bring down, right? I bring down my 725, half of 50 is still 25, and times my V squared. How do I get V squared on the right-hand side alone? So how do I get rid of my 25? What do I need to do?
Divide by 25.
Good. The inverse of multiplication is division, so if I take 25 and divide that on both sides, what is 725 divided by 25? Okay, so this becomes, and I'm gonna kind of move over here, 29 equals my v squared, right? When I do that, 29 equals v squared. And then as my final step, we save the getting rid of the squaring to the final step, and I have it written up on the board too, just to remind you. How do I get rid of that square? Hello? Yes, in the hallway. In the hallway. It had to be somebody who got off the bus, you know. Okay, all right, fine. Okay, how do we get rid of the square? Square root it. Right. So the inverse of squaring is the square root. So I take the square root of this to get v alone, but I have to do it to both sides. And what do we get when we take the square root of 29? 5.4 sounds pretty good. So this is going to be 5.4. Do not forget the units of the meter per second. And so that finishes off part 2. Is everybody with me so far? So it's not any different math than we've already done. It's just like one giant problem and like picking out what you need to use and when and how and all that. Okay, let's think about this part logically. If I'm at the very top, what do I have all of?
Kinetic.
Are you sure? We have all height.
Potential.
Potential. So if we are at the very highest point, we have all height. It's like at that split second when you're on that swing and you're at the highest point, right before you switch directions, there has to be a momentary pause, a momentary moment, right? A split second where there's no motion before you switch directions. Same thing with the skateboarder. He's going all the way up, that's as high as he goes, and then he goes back down. So if the potential is 1225, how much kinetic do you have in that split second where he's not moving? 0. Good. Okay, so let me ask you this. Well, we have kinetic and we have potential, so we can really solve for velocity with kinetic or height with potential. So let's just do our potential real quick. So if I have, it's going on. I get too close to this side. All right, so GPE equals mass times gravity times height. And so if I plug these in, 1225 equals, let's rearrange our equation. Let's rearrange it. Forgot, we can do that with our GPE. Okay, so if I'm solving for height, let me cover up my height, and what do I get? What equation would I set my height equal to? Michaela. Good. All right, so we're gonna do. Oh yeah. Try to stay back. Height equals GPE over mass times gravity. So I'm going to plug these things in. So height, obviously I don't know. 1225 is my GPE. I take my mass of 50 times my gravity of 10. Don't forget to do your multiplication first. So you're going to have 1225 divided by 500. And that's going to give me what? And be careful, because there's a few of you on that worksheet that we did Thursday that you wrote it like this, but then you still just divided by 50. You didn't divide by the 500. Okay, so what is 1225 divided by 500? Kate, what do you have?
2.45.
2.45? Let's just go to 2.5. So height is 2.5 meters, and we are down to our very last and final variable. So, kind of block this off, that's one step. So we're solving for velocity. So if I have KE equals 1/2 mass times v squared, and of course I'm using the kinetic equation because that's the one that has velocity in it. So if I take my kinetic of 0 equals 1/2, my mass is 50 times my v squared. I bring down what I can't do anything with. We already established that half of 50 is 25 times v squared. And then how do I get rid of my 25 again? Divide both sides by 25 because the multiplication, the inverse of that would be division. So 0 over 25 is what? 0. Okay? So 0 equals v squared. Well, what's the square root, or we are squaring velocity. So our hint says to get rid of our square, we square root both sides. And so what is the square root of 0? Are you serious? Did anybody realize this as we were going through it? That it's 0. If you have 0 motion, which is what kinetic energy is, don't you have to have 0 velocity as well? So, if your kinetic is ever 0, by default, velocity is also 0, and you do not need to do all this. I'm showing you this one time to prove that, hey, when you calculate it out, it is 0, but you don't have to do that. So if you see that kinetic is 0, then you know, recognize that velocity will be 0 as well. Yes? Makes sense? There's a lot going on here. Agreed? But none of it is anything different than we've done, this whole unit with these equations. And you guys did really well with the equations. I was pleased with your calculations, and I have those papers that I do want to return to you. Good? Okay. Hopefully you had enough room where you could do your work and where you could kind of follow along so you could look back at it as kind of a nice example. Let's go ahead and stop here. We'll do another practice one tomorrow.